Oh my God, it took me forever to try to figure out how to show this test from Edmodo onto a video so we can review it real quick. But I'm here, so we can take a look at it. Question number one, mutual attraction between nuclei and valence electrons of different atoms that binds them together. That's the definition of chemical bond. Number two, as atoms bond with each other, they A, increase their potential. No, actually, it's a decrease in potential, so we can eliminate that. B, decrease their potential, thus creating less stable. Nope, they create more stable arrangements. C, increase the potential. We don't want that. D, decrease the potential while creating a more stable arrangements of the matter. And that is the correct answer, D. Number three. A chemical bond resulting from the electrostatic attraction between positive and negative ions is the definition of a B, ionic bond. Wow, I can see when I copied and pasted in the problems, it had answer A, covalent, answer C, charge bond. That's really a bad way to write a test. Try to be more aware of that when I write the tests this evening. Number four, chemical bond formed when two atoms share electrons is a covalent bond. Five, if two covalently bonded atoms are identical, the bond is nonpolar and covalent. Answer A. 6. When atoms form a bond and share electrons, the electrical attraction of an atom for the electrons is called the B, electronegativity. Remember, electron affinity would be if the atom was by itself, not part of a bond. 7. If the atoms that share electrons have unequal attraction for the electrons, then that is a polar bond. 8. Most chemical bonds are a little bit of ionic character and a little bit of covalent character. So the answer is C. Remember, there's no such thing as a purely ionic or covalent bond. The greater the electronegativity difference, the greater the percentage of ionic character. The less the electronegativity, the greater the percentage of covalent character. And boron trifluoride, where the boron has an electronegativity value of 2 and fluorine has an electronegativity value of 4, the actual bond is polar. Now, in the chapter we just studied, the bonds actually cancel each other out. It's a nonpolar molecule, but the bond itself is polar. And but the electronegativity difference is greater than 1.67, so it's actually technically considered an ionic bond. Number 11. What principle states that atoms tend to form compounds so that they have 8 electrons? Well, that would be the octet rule. The electron configuration for nitrogen is 1s2, 2s2, 2p3. How many more electrons does it need? Well, we need 3 more to complete the p shell. 13. The ions in an ionic compound are organized into crystal lattices. That's the property of an ionic compound. 14. Which of the following is not a property of an ionic compound? They tend to have high melting points because of all that Coulombic attraction. So that one is the one that's out. The rest meet the definition for ionic compound. Number 15. Compared with ionic, molecular covalent compounds have a higher melting and boiling point, or have a lower melting and boiling point. All right, ionic compounds tend to have higher melting points because of all that Coulombic attraction. They do form crystal lattices, but they're saying compare ionic with covalent. So I would have to say that C is the better answer, even though B is not untrue. 16. In metals, the valence electrons are delocalized. So that was the whole big thing about metallic bonding. That is a property of metallic bonding. Metals are malleable because metallic bonding. Now, if it was rigid, they would fracture apart, but they don't. So allows one plane of ions to slide past another. That would be the correct answer. 18. As the strength of a bond between two atoms increases, the electronegativities also increase if we're talking about a non-water environment. So the answer is B. Number 19. Which of the following general properties is a general property of an ionic solid? A is false. They do form crystals. B, they have high melting points. C, they're insoluble in water. That's not true. Most of them dissolve in water. They do conduct electricity in the melted form, or molten form is what they call that. And that is a property of an ionic solid. So answer is D. Number 20, the sum of the radii. Okay, so of two ions is, well, the rest are radii. So if you're adding two radii, the only answer could be diameter. So the answer is A. Half the distance, so radii, right, is the line joining the nuclei of two bonded atoms within a molecule. Okay, so it's within the molecule, not between molecules. If it was between, it would have been answer A, van der Waals. But it's B, covalent radii, because it's within the molecule. Number 22, minimum distance between the nuclei is the bond length. Number 23, in general, within a group or column. All right, so we're going down the group. What happens to electronegativity? Electronegativity decreases. So the answer is D, due to increased shielding and quantum energy. Which of the following lists elements in order of increasing? All right, so the first one, bromine, chlorine, fluorine, that's a group trend. And that would be the answer, because bromine is further down the column and fluorine is at the top of the column. Number 25. Type of bond that's formed as a result of a transfer of electrons. We go back to middle school, even though I know you learned nothing there. That would be an ionic compound. Number 26. Which of the following is a general property of covalent compounds? They tend to have low melting points. First one, very hard, would be neither ionic or covalent. Some ionic compounds are hard, some of them are very soft. Same thing with metals. Can be shaped with a hammer, that's a metal, and conduct electricity, that's also a metallic property. So the answer is C. Number 27, the type of bond that involves delocalized electrons, so that is metallic. And 28, if two covalently bonded atoms are not identical, then we have a polar bond, so B. Octet rule says that chemical compounds tend to form so that each atom has an octet of electrons. Where? In the valence shell, the highest occupied energy level, so the answer is A. Number 30. When two or more atoms bond covalently to form neutral particle, then we call that a molecule. A crystal would be for ionic compounds. Polyatomic ion would be a special arrangement where you have covalent bonding due to a dative or coordination bond. And kernel is the noble gas core for an atom. 31. Which of the following compounds would contain covalent bonds? Well, they all have metals and nonmetals, but the sodium sulfate, the sulfate's a polyatomic group, and a polyatomic group, remember, you have covalent bonds, even though one of them's dative, to form a charge. So the answer is B. Number 32, weak forces that hold molecules to each other are termed van der Waals forces, or intermolecular forces. 33, the particles that produce or cause dispersion. That's a good question. It's the movement of the electrons. Remember, they're not always evenly spaced, and if they move to one side or another at a given microsecond, that's going to create a temporary dipole, temporary surplus. Polar molecule that's had its electron cloud distorted by another polar molecule is a dipole-dipole force. Again, the key here is polar. So if it's permanently polar, it has to be dipole-dipole, not diffusion. I mean dispersion, not what's called a London dispersion force. 5, order the intermolecular forces from weakest to strongest. London dispersion is always the weakest. Dipole-dipole, then hydrogen bonding, and then ionic would be the strongest. So it's answer B. Number 36. The bonds between hydrogen and oxygen within a water molecule. Now, I selected this problem, and I think it was Shreyas that pointed out to me that I had the answer wrong. Kind of careless here. I was looking for a problem that involved hydrogen bonding, so when I saw that and I saw hydrogen bonds in the answer, I thought that was it. So I went back and gave Block B credit for it, and Block A, I corrected the problem before you took the test. But that is actually within the molecule they're talking about, so it has to be intra, not intermolecular, so it has to be answer D. And then number 37. A certain solid that is hard, has high melting points, and non-conducting unless it's melted are all properties of ionic, so the answer is B, sodium chloride. All right, well, that is 12 and 14.3, so thank you very much.